1. In this example, we need to evaluate the following integral. It's an indefinite integral. The numerator will be 9 minus x squared, and the denominator will be simply x squared dx. So I'm looking at the numerator, and I see that I have 3 squared minus x squared, right? So a equals 3, and the substitution will be okay, I can write 9, the square root of 9 minus x squared. I'm going to write it as the square root of 3 squared minus x squared. So a equals 3, and we substitute x with 3 sine theta. Okay? If we substitute x, we also need to produce an expression for dx, and once you substitute, then you come up with dx equal 3 cosine theta d theta. So we can substitute now, and let's look at the numerator. Okay, the square root of 9 minus x squared. Now going to read the square root of 9 minus, again, x squared is 9 sine squared of theta. Factor out the 9, square root of 9 is 3, get 3 of 1 minus sine squared theta, and 1 minus sine squared theta is cosine squared, so we end up having 3 cosine theta. And now you can see the beauty of this substitution. Okay? If we call the integral, let's give it a name, I. We started with the square root of 9 minus x squared over x squared dx. Now we end up having the 3 here, so the numerator becomes simply 3 cosine theta. Okay, let's not forget the dx. dx also is 3 cosine theta d theta. The denominator is x squared. It's simply 9 sine squared of theta. Okay, now we have some nice stuff here, don't we? Let's see, what do we have? 9 times 9 divided by 9, that goes away. We end up having cosine squared over sine squared d theta, or we end up having the integral of the cotangent squared d theta. Did we do the cotangent squared on Tuesday? If not, time to use our arsenal of trigonometric identities. Okay, let's recall that the cosecant squared of theta is cotangent squared theta plus 1. So cotangent squared theta is cosecant squared minus 1. This is a very useful substitution. Remember, we did it with the tangent squared. We substituted tangent squared with the secant squared minus 1. So we're going to substitute the cotangent squared with the cosecant squared minus 1. Okay? So here we go. Now we have I, our integral, instead of cotangent squared, will be cosecant squared theta minus 1 d theta. Right? The rest is easy, I think. Right? What is the integral of the cosecant squared? What is the antiderivative of the cosecant squared, guys? I'm sorry? try something else? Somebody said it correctly, I think. I'm sorry? That is correct. Negative cotangent theta. Remember, not square, I'm sorry, cotangent. The derivative of the cotangent is negative cosecant. Okay? So the antiderivative of the cosecant squared will be simply the cotangent. And of course, we have plus theta. Or minus theta. Plus c. Now, this is not a solution yet because this is a solution in theta. We started with x. We need to have a solution in terms of x. So we need to convert cotangent theta and theta back to x. Well, how are we going to do it? We're going to use the definition of x, the substitution. So if x equal, okay, let's write a comment here. We need to convert the solution to a solution in terms of x. Okay, so let's go back and say if x, this is page 2 I believe, if x equals 3 sine theta, then sine theta equals x over 3, right? And theta itself is the inverse sine. I'll write it as sine to the negative 1 of x over 3, like so. We got the solution for theta. What about the cotangent or the negative cotangent? Here we have two possibilities. One possibility is to use all kind of trigonometric identities to express the cotangent in terms of the sine, or in terms of x, right? If I can express the cotangent in terms of sine, then the sine being x over 3, then I can substitute. It's a workable solution. It's not that hard, actually, but it's a little bit on the messy side. Here's a nifty way to do it. Okay? Remember, the sine is x over 3. You may remember this technique from trigonometry. If you come up with a right triangle and use the SOHCAHTOA definition of trigonometric functions, SOHCAHTOA, remember sine, opposite over hypotenuse, and so on. Well, the sine is opposite over hypotenuse, so put x opposite, put 3 as the hypotenuse. Now, the adjacent will be the hypotenuse squared, the square root of the hypotenuse squared minus opposite squared. So it will be the square root of 3 squared, or 9 minus x. One thing with this technique, you're going to see that we're going to recover the radical that we started with. Now, I'm looking for what? I'm looking for the cotangent, right? Based on this, the cotangent equals, cotangent is adjacent over opposite. Tangent is opposite over adjacent. So adjacent over opposite will be the square root of 9 minus x squared over x. So we have an expression for theta, we have an expression for cotangent theta, and the solution or the answer, in this case, we're going to say I, the integral, will be negative the cotangent. Well, the cotangent in terms of x is 9 minus x squared over x, and then minus theta, and theta is the inverse sine of x over 3. Plus c, thank you. Okay? So is this a wow moment or what? Did you see we use all kind of arsenal We use arsenal of tools. We kind of interesting solution.